This is the differential equation problem, no calculator. So they're giving us the differential equation, and then y, which is the same as f of x, is the solution, and they also give us a point to work with. Okay, part A, we're going to use Euler's method with two steps of equal size, starting at x equals -1. So they give us a point to use, -1, 2 to start, and we want to get to f of 0. So in order to get to here, two steps, we're going to use delta x is 1/2. So remember, Euler's method, all you're doing every single time is writing the equation of a tangent line. Writing the equation of a line. So let's go ahead and plug this in. So I have y minus 2 equals, I need the slope at this point. Your slope is dy dx, which is given. So I want to know what happens at -1, 2. And if I plug that in and punch this out, this should get me to 6 minus 2, which is going to be 4. So there's my slope. And remember, this here is your delta x, right? The only variable you should have here is your y value because we're approximating the y. So this is delta x. So y is really 2 plus 2, if I move that 2 over. So your next y coordinate is 4. So we're going to go move the x coordinate up by 1/2. So I'm going to get to -1/2. And there's your new y that we got. So we're going to do the same thing again. I need the slope again. So slope, we're going back to this equation at -1/2 comma 4. So 6 -1/2 squared minus -1/2 squared times 4. Punch this up. This should get you all the way to 1/2. So my equation is y minus 4 equals slope. Delta x is again 1/2. So really it's 4 plus a fourth, which is 2/5. So this is the Euler method approximation for f of 0. Okay, part B, we want to, let's see, it gives us the value of the second derivative is -12, and it wants us to write the second degree polynomial about x equals 1. So this is going back to our series unit, but remember, to write the polynomial, we start with the value of the function at -1. First derivative times x plus 1. It's about x equals -1, so we're going to do x plus 1. Second derivative at -1, x plus 1 squared, all over 2 factorial. So this was given is 2. The first derivative we found out from when we did Euler's method was 4. I have x plus 1. Second derivative, they tell us, is -12, x plus 1 squared, all over 2 factorial. So that's my second degree Taylor polynomial. And lastly, part C, they want us to find the particular solution to this differential equation. So finding the solution means that we need to come up with the original equation, y. So step 1 has to be separate the variables. So the y's with the dy's, I have to get the x squared by itself. So I'll factor that out. And then I'm going to go ahead and divide by the 6 minus y. Okay, step 1, and this is going to be your first point, is can you separate the variables correctly? Notice this is going to be a 1 over u, but notice your u is 6 minus y, your du is a -1. So remember, we need that reciprocal. So we have a negative natural log of 6 minus y, x cubed over 3 plus c. We need to solve this for y. We have to get rid of the negative sign first. So I'm going to divide by a negative. Now this c, remember we talked about it's just a constant. It could be a positive or negative. So if we divide by a negative, it's still a number. So I'm going to keep it as plus c. If you did minus c, that's fine. And then remember, did this idea. So we have 6 minus y equals, and then remember this is the same as this using the properties of exponents, but this is really a number. So this can be rewritten like this. And this will make it easier when you have to plug in the point or simplify your answer for multiple choice. So if I solve this for y, I get 6 minus c e to the -x cubed over 3. So there's my general solution, but I do need to find that big C. So there's my point they gave me. I'm going to go ahead and plug that -1 in. So this becomes positive 1/3, -4. So 4 equals c e to the 1/3. So c is really 4 over e to the 1/3. And then I can go ahead and just plug it back in for the c into the original. So my final equation is 4 over e to the 1/3 e to the negative x cubed over 3. And there are various different ways you can write this answer.